Okay, so now we're going to stay with the exact same scenario, okay? So we're launching it at 40 meters per second, 20-degree incline there. Boom. All right, and what we want to know is how far up does it go? Way up here. What is that going to be? Let me call that H max. Okay, so let's find H max. Okay, now the way that we're going to do this is by using our vertical information here, okay, and find the time that it takes to get up that high, okay. The question is, though, we don't know what the time is to get up there, okay. Now, I mean, before, when we found time of flight, we knew how far we had fallen, start to finish, that kind of thing. But this time, we don't know the change in vertical position, and we don't know the change in time, either one. Okay, so we're gonna have to figure that out. So, fortunately, okay, we've got some other tools at our disposal. All right, now don't forget about these. But when we talk about the vertical aspect of the motion, that's a free fall problem, which means, sure, we have Optimus Prime, but we also have Sam, and we also have Bumblebee. Okay, so what we could do here is we could say, well, let's take a look at, let me pick Bumblebee. Okay, so we could say I've got V final squared, V initial squared, plus 2A, and we'll say delta Y in this case. Okay, so over here, all right, the initial speed is my vertical component right there, that 13.6. All right, and once I get up here to the top, then my final speed is 0. Okay, so I can take Bumblebee, I can rewrite it. Say this, so we got Vy naught squared. Whoops, sorry, it's not a Vy naught, it's V naught Y squared plus minus 2G delta Y. Okay, now look here, see, this is a positive A, okay. G is always a positive number, okay. G is always positive 9.81. Since we're going downhill, we're actually saying that A is negative G. All right, that's how that's working. So that's why I went to a minus sign on that, okay. Negative G. Then when I run my numbers on that, okay, using my delta Y, okay, let's just do a little bit of algebra here. Whoops, I want to get the other color. My delta Y is going to become V naught Y squared divided by 2G. Okay, now once I plug in all my numbers there, what I get for my delta Y turns out to be 9.538 meters. Okay, again, hanging on to an extra decimal place there. Okay, but the question is, what is that particular delta Y? What is that? Okay, well, that delta Y right there actually is the distance between the top of the cliff and the apex of the trajectory. Okay, so I'll tell you what, let me call that delta Y prime, so that in my drawing right there we can say there's my delta Y prime, just like that. Okay, and so then H max is going to be equal to 20, the height of the cliff, plus my 9.538 number. Okay, and so once we stick with 3 sig figs, we get 29.5 meters. Okay, so we could say it a couple different ways. We could say the projectile ends up going 9.5 meters above where we fired it, or 29.5 meters off the valley floor, so to speak. Okay, it just kind of depends on what we're looking for, but either way, it's fine. We got it. Okay. All right, now I want to show you something else though, because we've got Bumblebee, but I don't want to leave Sam out, okay, because we've got Sam also. So let me make a little line here so things don't get too messy. Sam is, oops, not that. Sam is V final, V initial plus A delta T. Okay, now let's play the same game. Okay, so we'll launch it up at a certain speed, 13.68. That's our component. Okay, the acceleration is down, and we're going to figure out, start to finish, how much time does it take to stop. Okay, so my final velocity becomes 0 again. My initial, again, becomes V naught Y, and I've got minus G delta T. Okay, and now if I solve for my delta T, it's going to be V naught Y divided by G. Okay, and when I do that, my delta T turns out to be 1.394. Okay, again, I'm retaining an extra digit. So that's how much time it takes me to get to the apex of my trajectory. Okay, just like that. Now, that doesn't tell us directly the height change like we had over here with Bumblebee. What we would have to do is then we'd have to take this delta T and we'd plug it in here. And that's going to end up giving us delta Y prime. Okay, and it's going to be, you can run the numbers, and you should for practice. You're going to get the same value, 9.538. Okay, so either way you want to do it is just fine. It doesn't matter to me. Okay, it's good news, bad news kind of thing, like we've seen before with kinematics. There isn't always one certain way to do it. Okay, sometimes you just got to head down a path, just put your head down and go. All right, see where you end up at. Okay, and one person might go one way and the other goes the other, but they could end up at the same place. Okay, now this approach where we find the time could be helpful if we wanted to know what is the range here. Okay, where are we there? Let me call that R prime. Once we're at the apex. Okay, so how far did we go? So if we wanted to know that, then we could come over here and we could put our time 1.39 in over here, and then that's going to tell us what our R prime value is. Okay, so there's no do it this way, don't do it that way. It's, just it all comes out in the wash. Okay, so it just depends on what you're looking for and how you want to proceed with it. Okay, all right, now we'll do one more example with this exact same scenario, and that's going to be how fast is this thing going when it hits the ground, and if you think about it like an arrow, what angle would it be sticking up out of the ground as? Toink! Where is it at? Okay, so we'll do that one next.